Okay, so when I look at this problem, I'm just honest with you guys, my brain kind of shuts down. I've looked at so many FRQ3s, you've only seen a few. I have like a stack of them and I kind of go through and pick which ones we're going to do. And when I have to go through my FRQ3s, I'm telling you my brain just wants to run away and hide because I don't do well with the diagrams. I'm a visual learner, but something about taking a picture and matching it to this shape is not easy for me. It's just not, okay? So I have started, the more I'm doing, just like anything else, the easier it gets for me. So I want to kind of like approach this from a place of like, I'm not great at these. What can I take from this and get? So let me start. One of the things I will say that when you do FRQ, there's a lot of different answers. One of the things I had conversations with all students about with this FRQ is a lot of you didn't really understand the points that I chose, and there was a very large consensus of what you guys used for your points, which were also right. So I'm going to do this as if it was you, because that's what most of you used, and then I'll tell you where my points came from and why I used them, but they're both full credit, okay? So let me just start by saying, okay, I'll take a glance at that picture, but it really overwhelms me. The figure shows a robotic arm rotating in a circular counterclockwise direction that completes one rotation every 2 seconds. Huge, right there. Half of this first question is right there in that one little thing. One rotation every 2 seconds. What do you think we could compare rotation to on a sine or cosine graph? Period. Cycle. How many points is one period, one cycle, one rotation? How many points? How many points? 5. 1, 2, 3, 4, 5. One period or cycle, in this case rotation, is always 5 points. That's always how we break that space on the x-axis up. So what I just learned is that from point F to point P, which is one cycle, 5 points, it has to be, the x-axis has to be a total of 2 units on here. Whether it's from 4 to 6, 81 to 83, negative 17 to negative 19, it has to be 2 points. So keep that in mind. As the arm rotates at a constant speed, the height of S above X periodically increases and decreases. That's my brain starts to get fuzzy with that stuff. But here's another really important part. At time t equals 0 seconds, S is at the lowest position, 6 inches directly below X. So this is what a lot of you did, perfectly fine. You said, here's my lowest point, that's 0 seconds, it's 6 units below. And if you look at the picture, okay, that makes sense. Right here, I'm at negative 6, okay? And then it says S is 20 inches at its highest position, S is 20 inches directly above X. At the highest, we're at 20. So we just are basically, you don't have to write this on the graph, but we have a y-axis over here where we're at 20 at the highest, our maxes, and at negative 6 for our min. Well, really, we don't need the question anymore. We're done with the question, okay? We don't need anything else out of that. The rest of this is basic arithmetic. We should assume that these are spaced equally. And so let's finish up the y values. K is halfway between J and P. G is halfway between F and J. So I can just, to find the height of this one, what this y value is, I'm just going to do 2 plus negative 6 divided by 2. Just find the midpoint, the average of those two numbers. That is 14 over 2, which is 7. So I know that this point and this point, they're at a y value of 7. Right there, that's 1 point. Your y values are a point, right there. X values would be another point. So let's fill those in. Same math, guys. 20 plus, no, sorry, that's not what I meant to say. Back to, I was looking at that as if it was X. Back to the fact that from here to here is 2 seconds, okay? And remember, our X value is time. So at 0 seconds, we were here. So if 0's in the middle, think of it like this. What am I going to have on either side of it that will equal 1, 2? This would be -1, and this would be 1. So from -1 to +1, that's 1, 2 seconds, okay? And then how do I find this one? That's what I was about to do here. -1 plus 0 divided by 2, that's -0.5 or -1/2. And then between 0 and 1 would be 0.5. That's 2 points right there. And really, we got most of it out of 2 little sentences in that word problem. Okay? Do we understand that? Just that. Question on that, because I'm going to compare it to my. Okay? All right. So where did my numbers come from? Because I got this question a lot. And if you haven't looked at it yet, this is worth talking about, because I'm right. Let's pretend this is my answer, and let's pretend that's your answer. We're both right. Both of us get full credit. I decided that I knew that I was going to go from 1 second to 3. I started at 1 here, and going out 2 seconds would make this 3. So from 1 to 3 is 2 seconds. Why did I do that? I don't know. I just didn't feel like having negative time. On these, it's okay to have negative time. I just wanted to make mine more real. I don't know. I made it harder. This way is probably easier. But let me just show you, because this is important. From 1 to 3 was 2 seconds. Halfway in between 1 and 3 is 2. Halfway between 1 and 2 is 1.5. Halfway between 2 and 3 is 2.5. So my x values are good. And my y values match the y values here. Okay? But why is mine okay? Well, what you guys have to remember is, I'm going to really mess this graph up now. These graphs are periodic, sinusoidal. They keep going forever and ever in both directions. Okay? So, it's kind of like, I'm so sorry, I should have had that further down. Pretend that's just another one of those. This would be just like F. This would be G and J and so on, okay? So in my answer, I had 2, -6. That makes this 0, -6. It's the same point. They're coterminal. 0 and 2 are at the same place. Remember, every 2 seconds you end up back at the same place. So I just backed it up and I just called that 2, 6, -6, sorry, just so I wouldn't be in negative time. I could have also called it this one. What would this one be? What would this point right here be? It's exactly the same distance. So it depends on which one we're using. Let's pretend this is 2, -6. This would be what? 4, -6. It's exactly one thing away. 1, 2, 3, 4, 5. We start and end at the same place. Just like we start and end at the same place. 1, 2, 3, 4, 5. These are coterminal. Okay? Every 5th point, it's the same place. So, if that confused you, I apologize. If you thought of the lowest, if you called this 0 and you called this and this -1 and 1, what matters is that from here to here, your x values span equally, a total of 2 seconds. And I don't think the y values are negotiable, right? How high and how low it goes, and then in the middle of it, okay? Now, here's the really good news. Let's pretend you are super confused on this problem. And I'm sure there are people that are. And you put in some values, and I'm going to make up something really ridiculous. So let's pretend you made this, I don't know, 7, 15, and this is 20, 15, and all the stuff in between. And you called this, I'm just making this up, 4, 7, and then, I don't know, 5, 7, and you just made a mess of it. Okay, let's pretend you did that. Okay, this person got no points on here for that part of the question. Okay, let's look at the back. When you go to this next part, which I'm going to show you, of course, how to do, listen carefully, because this blew some students' minds. If I base my A, B, C, and D off of my terrible numbers that I got no points for, but my A, B, C, D match this yucky graph, I will get those 2 points. It's 2 different skills. Do you know how to find the amplitude and the phase shift and the midline? Do you or not? That's what this is testing. So this question is independent of this question. You're going to use whatever you got here to answer that. And even if this is wrong, as long as you knew that, for example, to find my amplitude, I know my graph is a mess at this point, but my amplitude is from the midline to a max or a midline to a min. These are the same direction, the same space, right? Length. So from 7 to 20 is 13, right? So I know A is 13. That's the right answer. But let's just say I used this graph and I said, oh, from 4 to 7, that's 3, right? No, sorry, 7 to 15 would have been 8. So I would have said my amplitude was 8. Well, as the grader, me, I would have to go back to your graph and see, okay, like that person got no points on the first part, but they obviously know what amplitude means. They know it's from their midline to their max or midline to their mid. And I don't know if my picture makes any sense, but do you get what I'm saying? So my point is, don't just look at this problem and be like, I'm not even going to try it. Try it. Even if you fake it in here, because you know how to find an amplitude and you know the midline. Look at this. I know I'm getting a little carried away, but I want to make sure you guys understand this. What if I have my midline? If I know that I'm totally going to get this wrong, I'd be really smart to make my midline the same number, even if it doesn't match anything to do with the word problem, because when I get to here, midline would be 8, and that matches my graph. You guys see what I'm saying? Am I making sense as far as like how you can fake it till you make it? Okay. Let's do the real answers though, okay? So we found our amplitude, which was the distance from midline to max or midline to min. Find what one makes you happy, okay? Just that space. It's halfway. No, it's the distance, okay? B is not your period, okay? Remember, period is how much of the x-axis we use to make our 5 points. And we already talked about that, 2 seconds, okay? The period, though, has a formula, 2 pi over b. Well, we don't need the period, we need b. So just like we've done a million times in this class, fill in what you have and solve for what you need, okay? So the period is 2, we'll find b by multiplying. And this is a non-calculator portion of the test, so you would want to show a little bit of work, okay? I know a lot of you can do this in your head. You don't have to show every step really, but show some calculations of how you got your B. So big mistake is people will put their B value as their period. They're not the same thing. They're related, right? They have a relationship, but they're not the same thing. Okay, midline, let's skip to that. Midline is 7. Right? It's what your middle y value is. It's 7. It's labeled as that. Oh, sorry, that's D. Okay? So all that's left is phase shift. C. We always, remember we said, we're going to pray to the math gods that we can put a 0 here. And in this case, we can. Here's why. This question will always be a picture with a word problem that goes with the picture. Okay? So that's going to change from question to question. But what will always be the same is you'll have a graph with 5 points marked, these same exact 5 letters, the F, G, J, K, P, I'm told. And you're going to be told in part B that it's a cosine or a sine graph. Okay? Those things are going to be always there. Now, what will change, though, is these points could either start up, start middle, or start down. So what you have to look at is the pattern, and remember what your patterns are for sine and cosine. So this is up, middle, down, middle, up. That's cosine. If our pattern matches this word, then we don't need a phase shift. Okay? Cosine is supposed to start up, so this is fine. It can also start down. Let's pretend F was starting down, and we were going down, middle, up, middle, down. That's still cosine. That's still a C of 0. But what would change if cosine started down? What would change in this? What? A would be negative. Yeah, that'd be a flip. Okay? It's not a phase shift. It's just a flip. So let me say it again to make sure you guys understand. Up, middle, down, middle, up. Cosine with a positive a. Down, middle, up, middle, down. Cosine with a negative a. Neither of those situations is a phase shift, okay? But what if we had to put a phase shift in? If this said, for example, sine, let's pretend that everything is exactly the same except they put sine here. You say, okay, sine starts in the middle. Middle up would be a positive a, middle down would be a negative a, but it's middle up, middle down, middle, or middle down, middle up, middle, okay? This doesn't start middle. I have to start my graph at a middle. Which middle? Doesn't matter. This is why I pray I don't have to grade this one this summer. There's too many alternative answers to these that it's going to make me crazy if I have to grade this one. But anyway, so we can start at any middle. You can go back. You can go forward to this one, forward to this one, forward to this, any of them. It doesn't matter. But you just have to do the correct one. First of all, if we're going to phase shift to the right, our C value would be negative. If we phase shift to the left, it's positive. Remember, it's always opposite. Horizontal movement is always opposite. So to the right is negative, to the left is positive, okay? So again, let's do the simplest one. If I'm going to phase shift to here, how far apart are these? How far to the right did I shift my graph? Sorry to have you guys look at this again. These are all how far apart. -1, -0.5, 0, 0.5, 1. How far apart are they? How far? Just 0.5, right? Is that what you said? Oh, 0.5 you said. I thought you said 2.5. Okay, 0.5, right? That's the distance between each of these, 0.5, 0.5. So my C value would be negative, because I'm going to the right, 0.5. That's what I would write. I could go all the way out to here. It'd be 1.5, right? I could go backwards. I could have called my first point back here, and that would be positive 0.5. But they're all correct, okay? That's only if our pattern doesn't match the equation they give us. We hope and pray, because that's kind of a pain. But is it really that big of a pain? It's not too bad, right? It's really not, okay? And so I'm going to move on, but if there was any part of that you need a little more clarification, call me over. I'm almost done, and then we can chat one-on-one. Last part of FRQ3, these two questions will be identical on any FRQ3. They'll always be the same. Well, I mean, the only thing that could change is what 2 points. This question is saying, refer to the graph of H in part A. The t-coordinate of K is t sub 1. The t-coordinate of P is t sub 2 on the interval of t sub 1 to t sub 2, which in this case is K to P. So from K to P, that's what we're talking about. Look at K to P. Oh my gosh, this is embarrassing. K to P is right there, okay? So what's happening from K to P? So let's narrow it down here by positive or negative. Well, from K to P, we're positive, right? That's a positive part of the graph. That's going to be A or B, okay? And increasing or decreasing is not concavity. It's literally, is it going up? Is it increasing? Down is decreasing. So from here to here, we are increasing, okay? If it was like F to G, that would be positive and decreasing, okay? So just, that's what this is. Positive and increasing. Your answer is A, multiple choice, okay? Part 2 will be exactly the same question. So describe how the rate of change of H is changing on that interval, the interval of K to P. When you hear that rate of change, they're asking about concavity. This is the part of the FRQ you always are going to use the word concavity in the sentence somehow, okay? So this is concave down, okay? That's concave down. So that means the rate of change is what? Decreasing. Remember, down, decreasing, okay? So you want to put that in some kind of fancy-sounding mathematical question. And so I want to talk about that real quick. I wrote, and the trick, as I told you, is to, you don't have to reinvent the wheel. Take the question, the prompt, and put parts of it in your answer. Like, just regurgitate it. So I wrote, because the graph of H is concave down on the interval t sub 1 to t sub 2, the rate of H is decreasing on this interval. That's one way of many, many, many ways of saying it. You definitely want to refer to the graph as H or H of X. This is something I just read. Like I could see me saying, but because the graph of it is concave down, they don't want to hear it. They want you to use good math language. So referring to it by its name, and it's named in the prompt somewhere, H of X, or H is both fine. It's like a nickname, full name, H of X, nickname H. Okay, so just think about using math language in there. And it's really just regurgitating what you see right here. Okay? Do we feel a little bit better about FRQ3? Okay. All right, what I'm going to do right now is I'm going to put up the multiple choice key because some of you need to grade your multiple choice. So when you get it done, as I'm bebopping around, please let me know so I can write it down. It's just for my records. It's not for a grade. Don't stress about it. And I am here to help. Go on Canvas if you need to for any of the other keys. Or I have some hard copies up here. Just make sure I get them back. And I will be around to help. Very simple. I don't think I did attendance.